Welcome to Swan Analytic. This video is the second part of macro programming in SAS. So if you have not already watched the part 1, please do watch before proceeding to the second part. In the first part, we looked at macro block, how to create a local macro variable using the macro block. We also looked at proc SQL, how to create macro variables using proc SQL. And in this video, we will see how to create macro variables using calls input. Calls input is one of the ways of creating macro variables. In calls input or in calls input text, so there are both are quite similar. Just that calls input text will remove leading and trailing blanks in addition to the same operation that calls input does. So calls input x means strip. It's actually strips the variable of its leading and trailing blanks. So it's more or less the same operation that calls both the calls input and calls input text does. So let's see how we can create a macro variable using calls input text. When we create a macro variable using calls input text, we are not really interested in creating a data set. Since we are not interested in creating a data set, we are using data underscore null underscore. And the syntax is calls input text, name of the macro variable within quotation, and the value we would like to assign to the macro variable alpha. In this scenario, it's alpha. So here we are assigning a value of 0.05 to alpha. So let me run this program and print the value of alpha. When I write %put, as you may remember in the previous video, part 1, we saw that put function, we use %put statement to print the value of a macro variable in the log window. So let's print it, and we can see that the value of alpha is resolved to 0.05. Now let's look at other applications. We are taking a count of the number of males and females in the dataset class. We have SAS.class dataset, and the class dataset we have name, age, sex, etc. And I would like to know how many males are there, how many females are there. So I'm giving sex in the table statement. You may be already familiar with procfreak and procfreak syntax. And when we do get the counts, so let's get the counts in from the dataset class. And the name is count. Name of output dataset is count. And we see that we have 9 females, 10 males. So once we have the count, we would like to create a macro variable, sex, which will contain the respective counts. So this macro variable sex and count, these are two macro variables, two variables we have in the output dataset after running a procfreak, sex and count. We would like to have the value of 9 in females or F and the value of 10 in M. In other words, F and M will become two macro variables with their respective counts of 9 and 10. So here we are able to create two macro variables using calls input x. So let me run this and see what's the value of F and M are. So you can see we are getting a value of 9 and 10. So the value of F resolves to 9 and the value of M resolves to 10. So it's a pretty easy way of creating macro variables. And you will have, let's say you have more number of values, distinct values. Then you will have more number of macro variables for the variable sex. Let's say we have unknown and there are females, males, and we also have a category unknown. In that scenario, we will have one more extra macro variable unknown as well. For example, you may be denoted for unknown. In that scenario, we'll have 3 macro variables. So the value, we have got both the values for f and m now in the macro variable. And there is one more scenario where we are using SAS help.class data, cars dataset. And again, we are doing getting the counts based on origin. In the dataset SAS.cars, we have 3 distinct values for origin. One is Asia, Europe, and USA. So these are the 3 distinct values. So if you're not sure, we'll just go and check the dataset. And let's go to origin, where select the variable origin equal to, and now let's look at the look up distinct values. You can see we have Asia, Europe, and USA. So these are the 3 unique values we have for origin. Next, we are getting the counts. How many cars are produced in each of the 3 geographical regions, that is Asia, Europe, and USA. And then that particular output data set is cars underscore count. So in cars underscore count, you can see Asia, it's 158 cars, Europe 123 cars, USA 147 cars. Now we would like to have these values 158 in the macro variable Asia, 123 in the macro variable Europe, and 147 in the macro variable USA. In other words, we have to convert this variable origin, all the values of origin, into macro variables, and the values of total into the value of the macro variable. So macro variable Asia will have the value 158 and so on. So let's see how we can do that using calls input x. So it's the same approach that we did for sex for the dataset SAS.class. Same thing we are going to do for the cars dataset. And now we are running this calls input x and getting the values of total into origin. The total, let me just close this and take the cars underscore count. Yeah, total into origin. So I hope it's clear how we are getting the values. Now let's run this and see what's the values of Asia, Europe, and USA are. So it's resolves to 158 for Asia, 123 for Europe, and 147 for USA. So this is clear now. Next, we are getting the type of cars we are looking at the counts by origin and type. How many cars with respect to origin and type? When it comes to type means there are sedan, SUV, sports, etc. So these are the distinct vegan. So these are the distinct values of type. I would like to get the count of cars. How many cars in Asia are SUV? How many cars in Asia are sedan? How many cars in Asia are sports, etc. And so on. Similarly for Europe and USA. Next, we are going to use conditional statements to create the variable total. So we received the counts now, cars types. So let me just open the dataset cars underscore type. This dataset cars underscore type. And we can see that Asia hybrid cars are 3, Asia SUV is 25, and so on. You can see for Europe and USA like that. Now what I'm looking for is I want to know what is the percentage of cars that is hybrid in Asia, what is the percentage of cars that is SUV in Asia. So I'm taking the percentage for Asia, Europe and USA. So when I compute the percentages, I divide 3 by the total number of cars produced in Asia. 25 divided by the total number of cars produced in Asia. And what's the total number of cars produced in Asia? It is, I can just check again. I printed in the log window. 158 for Asia, 123 for Europe. So it will be 3 divided by 158 for Asia. That is the number of cars that is hybrid in Asia. So in order to do that, I need to get a total here for Asia, one more variable that contains the value total for Asia, Europe and USA. Remember that the total number of cars is different for each geographical region. Now let's get the total. And how do I do that? It's if origin equal to Asia, then total equal to ampersand Asia. Ampersand Asia was created in this particular step, and it's printed in the log window in this step. Similarly, when the origin is Europe, get the total as the value, the total count of cars for Europe, and so on. So I just ran this program and we'll see, get the dataset cars. Now you can see the cars dataset has got a total variable. The total will have the total count based on the geographical region: Asia, Europe to 123, Asia 158, and USA 147. Next, I am getting the percentage that is count divided by total into 100. That is count divided by total into 100. So I am getting 3 divided by 158 into 100, which is 1.9. Similarly for all the other rows. So you can see how I am able to capture the values of a macro variable into the dataset variable total and generate the percentages. So I have shown you a real-time scenario, a real-time example where we need to compute the percentages, and we can utilize the total for each column, the total for each geographical region, capture the value in a variable like total here, and compute the percentages. I hope that's clear here, how to utilize the macro variables to create a dataset variable and compute the percentages. So this is an application of the purpose of creating macro variables. Next, I will show you what is simget function. Simput function is to get the value of a data step variable into a macro variable. We have seen we are getting the value of total into origin. So we are creating total is a data step variable, and we are creating Asia, Europe and USA using the variable total. So that is how we are able to get the values of a data step variable into a macro variable. Similarly, we can also get the value of a macro variable into a data set variable. For example, we have created a macro variable. Let's say I want to know what is the total number of records in the data SAS.class. In order to identify the total number of records, I will give a condition end equal to end. End is a variable created when we create a data set. The last record has a value of end equal to 1. So when you give a condition, if end equal to 1, automatically SAS understands that you are interested in the last record of the data set. So the last iteration, underscore and underscore is the iteration, and then when n equal to 1, it's the last iteration, and the value of the last iteration is captured in the macro variable total. So total is a macro variable we are creating, which contains the last iteration of the data step, and the last iteration in the dataset class is 19. I know we already know the number of records in class dataset is 19 records. You can see the 19th record, the last record. So I'm trying to capture the total record, total number of the count of total number of records into the macro variable total. I'm creating a macro variable total, and let's print it and see. So you can see I got 19. It shows that I have total of 19 records in the data set. Now I want to get the value of 19 into a dataset variable. Dataset is also variable is total. You can give any name. I just give total. You can give any other name as well. So I'm creating class 1 dataset that contains the value of the macro variable, and that is I'm using sim_get function to get the value of a macro variable into a dataset variable. So let's open the count class 1, and we can see we got a dataset a variable total that contains the total number of records in the dataset. This can be useful again to compute percentages and all. If you want to compute percentages, this can be used as a denominator, just as we did in the previous step. So we have seen what is calls input, what the applications of calls input, and also what is sim_get function. Next we will see if-then statements. In if-then statements, where you might have already learned if and then statements in base SAS. This is similar to that in macros as well. The difference, one of the differences is that we will be writing %if and %then, but we are giving conditional statements. So here, for example, let me just clean up the work library before I proceed using the proc datasets. Just to clean up the work library, I'm creating a macro summary. This is the name of the macro summary that contains two macro parameters. We are creating two macro variables, var and vtype. You can call it macro parameters. So there are two parameters here. Based on the nature of the variable, we are generating the summary statistics. For example, the variable type is numeric. We are computing proc means and all the summary stats related to, such as mean, median, standard deviation, min, max, etc. On the other hand, if the variable type is character, or variable type is something like a categorical variable, and I have given here C, then we will be getting the percentages, counts and percentages. So the nature of the variable will decide whether we are going for a proc means or we are going for a proc freak. So this macro runs a conditional statement so as to generate the summary stats based on the nature of the variable. Now, V type is the nature of the variable. Here it is N means numeric, C means it's a categorical variable. So when the variable type is height is a continuous variable. It's numeric and it will go and run the proc means. So let me just run it and show you. So we can see we are able to get the summary stats like mean, standard deviation, minimum, maximum. And let me show the output data set. Ampersand var underscore stat. And what is ampersand var? It is, we are passing as height. So the name of the output data set is height underscore stat. Let me open the data set. So you can see I'm getting all the mean, median, etc. All those generated by proc means. Next, we have to notice that variable I'm passing in the class statement is 6. So we are getting the summary stats grouped by 6. So when we are getting the summary stats, that is mean, median, mode, mean, medians, mean, max, and everything, based on the variable we pass it in the class statement. So that's why we have for females and males, because it is a variable we are passing in the class statement or grouping variable. Next, let's try to pass the categorical variable, cholesterol status. So cholesterol status in this data set, hard data set, is something like desirable, high, or normal, etc. So based on the cholesterol status, again it's a categorical variable, or you can call it ordinal as well. But here we are getting the number of people who fall into each of those buckets, that is normal, borderline, high. So let's run this and see. And I make sure and remember that I'm getting it based on sex. So I'm segregating it by males and females. How many people fall into each of those categories. So it's a 2 by 3 variable. So 2 cohorts for sex and 3 buckets for cholesterol status. So we are getting female borderline, female desirable, female high, male borderline, male desirable, male high. We are getting the counts in percentages. So that is how now we are able to generate the summary stats based on prop freak, because it's a categorical variable. So that is how the if and then statement work. When it is a continuous value or indicated by n, we generate a prop means, and step ends here. If end, whenever you write a if statement, it will, we have to put the, sorry, actually whenever you write a do statement, we have to put a end statement. It's just like the base SAS. Whenever you write the do end, you always write the end. Whenever you write a do block, it should finish with end. Here it's percent do, percent end. So that's how if and then statements work in macros. So it will execute only the particular step where the condition is true. If it's a numeric variable, it will only execute this step and this will fail. I hope this clearly explains what's the difference, what is if then statement, if then do statement in macros. You can try it for many other variables as well. I have done it. You can try to generate the summary stats and see with which particular step is executed, whether it is this first one or it is a second one. V type is N or V type is C. And there is one more way of writing if then statement, just as we do it in base SAS. That is, we don't write the do step, person do. Here it is just then, and we will see how that is a bit different. Although the approach is same, you can just the syntax wise, it's a bit different. So here it's just the same as the we did here, pretty similar to this. The name is again person macro, person summary. Macro is name is summary again. One difference we see here, again it's proc means, and if statement is ending with end, if then do end, and we have a second block with if then do end, one for proc means and another for proc freak. Here the difference is actually in the output data set. When you output a data set, ampersand var underscore stat, just as you did before. In one scenario, you are computing the Q1, Q3, when the variable is weight, you're giving a conditional statement. When the variable is weight, generate Q1, Q3. And when the variable is not weight or any other variable apart from weight, compute min and max. So these are the only two steps that is different in this scenario compared to the previous one. So let's say you're creating a demographic data set and you have a couple of continuous variables like height, weight, BMI, and only for the weight variable the client asked you for Q1, Q3, quartile 1, quartile 3. Q1, Q3 are summary stats, quartile 1 and quartile 3. But for all the other variables like height, BMI, they want the min and max. They don't want Q1, Q3. In that scenario, you don't want to write two macros differently for weight one and for the rest of the variables, second macro. But instead, you could tweak the macro, one macro itself, such that you get both the summary stats as per the variable you pass in the macro. So here again we have two macro parameters, var variable and the variable type, var and v type. So when you are passing height, this condition will fail. The first condition will fail. So it will go to the else condition and it will execute and generate min and max. But when you compute, you are checking the variable weight, getting the summary stats for weight. This condition will be true. It will generate Q1, Q3, and because this is true, it will not go into the second condition. It will not go into the else condition. So let's check it out, whether this is working or not. So I just ran this macro. Let's call this macro now. For the variable height, and remember that for height, this condition should be executed and we should get min and max and not Q1, Q3. So I'll close this, and the name of the data set is height underscore stat. You can see I'm getting min and max. I don't get Q1, Q3. Now let's run weight for weight variable. Remember, we should be getting Q1, Q3, not min max. That's how we can verify our macro is running correctly. So weight underscore stat, I don't get min and max, but I would get Q1, Q3. So this becomes a way of verifying whether the macro is running correctly, executing correctly, and it's correctly running here. Next, we will look at macro functions. So I'm creating a program name. When we start a program in our day-to-day work, we write the name of a program. Every program will have its name. Let's say the name of I'm creating a table for adverse events, and I'm giving the name T-AE is the name of the program. Or I can actually give TAE underscore .SAS as well. So this is the name of the program. And the name of the output file, let's say I'm outputting a file, RTF file, and the name of the output RTF file is adverse underscore events. So I'm using %let statement and creating two macro variables. So these macro variables are created by running this step. I've run this step and it's created. Now, next step is to use what's the upcase function. Upcase is used to, I will be discussing a couple of functions we often use in SAS macros. There are although many other functions as well. So upcase function we are actually using for converting a value into uppercase. just as we do in base SAS. So PGM name we want to convert into uppercase. Correct? Remember it is a low case now. We can convert into uppercase. Similarly, I want to, let me now run it and see. And I'm printing it. What is the value of uppercase program PGM name? This I will remove because we are not really manipulating this. You can just percent put name, put name here. Let's see actually whether up PGM name has converted the value of PGM name into uppercase. So you can see it's converted into uppercase T hyphen A. Previously it was T is A small. Now it's T caps or uppercase. So this explains how uppercase is used. We also have a Cmp Arrays function, Cmp Arrays function. This function is used to remove multiple blanks and convert into a single blank. Also, it can remove leading and trailing blanks, kind of Str function. A combination of compel and Str function base SAS. For example, I'm getting the count of distinct types into macro variable n from sasab.cars. So there are type is a variable in cars dataset that contains the type of car. It can be SUV, sedan, sports, wagon, etc. So I want to get the distinct counts actually. How many are there? Unique ones. Let's print it. So I'm getting the value 6 here. Next, I want to create a macro variable result that contains the value where I am typing car types n equal to %n. So when I do that, let me run it, and I'll print it. I create a new macro variable result that contains car type and the count of distinct types of cars. And when we run the result, I'm getting car types n equal to 6. Notice here the gap between equal to sign and 6. What does this imply? It implies that there is a leading space. So this needs to be removed. And how do we do that? Using %cmp Arrays function. Let me show you a real-time example actually when we are using this kind of macro variables and why we need to use some important function like compress, left and all, Cmp Arrays left functions. So you can see where I'm creating a survival analysis table here. I have two cohorts, African American and white cohorts, and I want the big N. Big N is the total number of patients who are African American, total number of subjects who are white. So here both are 5. And when I'm giving the header counts, I'm using macro variables for giving these counts, ampersand n1, ampersand n2. Now, if there is a leading space like this doesn't look good when we send it to the client. So we have to ensure that these leading spaces are removed. So how to do that? So we can do that by using the Cmp Arrays function. So I am using Cmp Arrays function to remove the leading blank here. And now if I run the result, Let's see if there is a leading blank. You can see it's proper now. We don't have this leading blank here. I hope this explains what is Cmp Arrays function and how we can use it. Next, let's look at person left function. It is similar to that of the compress function. Again, you are using person left to remove the to left align the value of the macro variable. You get the same result again. I'm just printing result 1 with using the left function, and you are about again getting the value with the 6 left align, not without any leading blanks. So this left function, compress function, all these are helping in doing similar operations. Next, I'm creating a macro variable. Again, this is really just deviating from the topic. If you want to create a macro variable with quotations, you can use quote function before the with a quote function so that you get the values in quotations. The rest is same, we have already seen. Set a distinct origin, that is the unique values of origin Asia, Europe and USA into macro variable origin 1, origin 2, origin 3. So it origin 1 to origin 3. But you are in addition using quote function and step function. Step function removes the leading and trailing blanks, and quote function ensures that the values are in quotations. Now let's look into it. You can see Asia, Europe and USA are within quotes now. This is useful when you are using these macro variables for filtering some values from a character variable. So this is just a bit of deviation from the topic where we are discussing macro functions. But coming back again, scan function. So there are a couple of other functions as well, and we'll see how those functions can be used. Scan function is pretty commonly used. Let's say we'll see an example. Scan function is very similar to the one we use in base SAS. Again, we are trying to extract a part of the string using a delimiter. Here we have a program name actually variable name, macro variable name called ta.sas, stands for T hyphen adverse events, table of adverse for adverse events. And you want to extract only this part. That is, you are using period as a delimiter so that you can extract the first part, which is T hyphen AE, the value to the left of the delimiter, which is period. So let's print both name and PGM name. So you can see name is T-AE.SAS. PGM name you are creating using the scan function, and when you print name, you get T-E.SAS. And what is PGM name? T-E or T-AE. So this is how you can use scan function to extract the string, a part of a string. Now let's look at an application of scan function. This is really a useful and real-time scenario. And we can do multiple operations, not only what I'm going to show you. You can apply it in many different ways, but using a similar template that I'm going to explain now. So ODS output, I'm just going to run the proc datasets to get all the datasets that are in the SAS help library. In the SAS help library, we have cars, class, heart, city, etc. and many datasets. So I'm going to take all the datasets, identify the list of datasets that are there in the SAS help library. For that, I'm writing mem type equal to data, I'm going to output all the data sets in the output the name of all the names of all the data sets in the members data set. It's a new data set I'm creating. Let's open members. So you can see in the name column contains all the data sets names in the SAS help library. Next, I'm interested in only those with starting with letter C. So filtering for it in the same data set. Here data set, and I'm overwriting the data set, and you can see I'm getting only those starting with letter C. Num. So let me remove this part actually because it's not having the value for num. So I'm ensuring that num is not missing, non-missing. This is optional actually. If you don't want, you don't have to do it. It's just optional. Yeah, now I'm having all the values populated for numbers, and all the data sets are ready. In the all the data sets in the SAS library are indicated in the column name for starting with letter C. Next, we are going to get all the dataset names mentioned here into a macro variable, and the name of the macro variable is files. And when we get all the dataset names, we want to ensure that they are separated by some special character, and here I am selecting asterisk or star. You can select any character. Next, I am getting the count of unique names of datasets. There are 13 of them. 13 unique datasets are there, starting from 1 to 13. So all those, what's the total number of count? I will be getting 13 here, and n will be 13. And I will get all the values of the dataset names in the files macro variable. So let's run it and see. So files macro will contain all the datasets separated by a asterisk. You can see here. This is asterisk, separated by asterisk, cars, asterisk, city, day, asterisk, city, month, and so on. And the macro variable n resolves to 13. So we have two macro variables now, files and n. Next, I'm going to export all these data sets, all the data sets starting with letter C, into my local drive. Now, remember, this is just one example, but the template will remain the same. The macro coding approach will remain the same. You can do proc export, or you can do any other step as well, procedures as well. But this approach is very useful, where we are using, coming to the context where you're looking at understanding the application of scan function and how we can apply it. So the first thing I'm going to create is a macro exp. In the macro exp, I'm writing a do statement, loop. I'm writing a loop that will iterate 1 to n times. N is now 13 here. So it 1 to 13. And what it will do is, I'm creating a macro variable ds, which will contain, in the first iteration, it will be 1. I will be 1 for the first iteration. Second iteration, I will be 2, and so on. And we know the value for files is like this. So let me just put it here for you to understand. Let me just put it in the comment box. Comment it. This for you to understand in pink color. So this is the values for files. Files will have values, car, city, day, etc. So each time it will go and pick the first one. First iteration, it will pick the first one. Second iteration, it will pick the second file. Third iteration, it will pick the third data set. Fourth iteration, it will pick the fourth data set, and so on until the last data set it will pick, which is the last iteration 13th, and it will fetch each time and export this file, this particular cast dataset in the first iteration, into this folder in my local drive into an Excel file. So SAS file is converted into an Excel file one by one until all the files are converted. So that is the step going on here, and here scan function is very important. So it is helps in getting one file after another at each iteration. So let's run and see whether how it's generating the results. So let me first go to this file path in my local drive. So you can see I have a lot of data sets here. Let me clean up all the data sets, remove all the data sets. Now it's empty, and let me run this out. Run now. This step from beginning I'm running. The end of the macro is here, and let me call this macro %exp that I created. Note that this folder is empty currently, but after I run it, it will be filled. Okay, let's check it out. You can see all the data sets are collected here, all those starting with letter C. So you can use scan function whenever you have to iterate through many files. So this is a very valuable operation. It can be a SAS dataset or any other files. Next, we will go and look at the index function. Index function is very similar to the index function in base SAS, where it's identifying the position of a character or a word. Here we are looking at the position of a character. So let's look at index function. If variable where macro variable a contains a value, a very long value, and we are creating a macro variable v to identify the position of v in this variable, macro variable a. So manually when we look at it, we understand the value will be 3, the first one, second one, third one. So at the third position is v. So ideally we should get a value of 3 for b. So I'm writing a statement here, printing v appears at the position ampersand b. Ampersand b is the position of v in a. A is a very long value. So let's check it out. So v appears at position 3. As we computed manually, same value we are getting using index function. Next is Str function. Str function is used to get a string, extract a part of a string. So here x is sysdate, and I'm now printing it. Sysdate is a system defined macro variable. So we are getting 20 June 15. Now let's extract only the month part using the Str function. So how to extract the month part? Just like in base SAS, how do you do it? You want to start from 3 and you want to read 3 characters. So you are starting from third one and reading 3 characters to get the month June. So let's run it and print the month. Macro variable MON. So you are getting June, JUN. So this is how we can use Str function. It's pretty easy and straightforward, similar to that of we have in base SAS. So if you're familiar with base SAS, this becomes quite easy for you. Sys function, sysfunc. This is a macro function that allows us to use many base SAS functions within a macro operation. So when you're dealing with macro variables, you can use base SAS functions using sysfunc. Let's see how we can do that. Translate is a base SAS function, and you can only use it when you're using %sysfunc. So your nesting translate function That is a base size function within the sysfunc macro function. We have a macro variable DAT with the value 5th of January 2021. Now I want to convert all the dashes, hyphens, what you can call a dash, all the dashes I want to convert into slash. So currently this is in this format. So I'm using sysfunc to create a new macro variable date1, which can use a translate function from base SAS nested within sysfunc to convert, to replace hyphen or dash with a slash. And now let's run that date1 macro variable. You can see previously the value that was separated by dashes are now separated by a slash. So that is how sysfunc, one example of sysfunc. Second example is how to get the mean, use the mean function. A base S function or statistical function that is used in base S can be used in macros for macro variables when it is nested within sysfunc macro function. We are having macro variables A, B, C, D with values 4 to 5, 3. And I'm taking the mean of all the macro variables A, B, C, D. If I don't use sysfunc, it will not generate the mean. It will not be able to get the mean of it. Only when we are able to use mean functions nested within sysfunc, we are able to get the mean values. So let's run it and see what's the value of mean stat. So we are getting the value of mean stat as 3.5. So that explains how we can use second example of how to use base S function in sysfunc macro function. Next, let's look at eval function. %eval. Eval function is used to do any mathematical operations. Remember, macro variables are character by nature. Now, x equal to 5, this 5 is treated as a text. And so when you write y equal to ampersand x plus 1, y equal to x plus 1, so ampersand x will resolve to 5 and plus 1, it will not really do any additions because 5 is a text. So it will be just treated as 5 plus 1 in a text format. Let me show it to you. On the other hand, when you use eval function and apply the same operation ampersand x plus 1, because you want to really add 5 and 1, in that scenario automatically it will the operation will be completed. It will add it. So let's run it. So x is 5, y is ampersand x plus 1, z is %eval of ampersand x plus 1. Let me print x, y, z. So x is 5, we are getting the value 5 here. The first value is 5 at the bottom. Let me just put some special characters so that it becomes legible. And clean this part and run it. So you can see x equal to 5, it's printing 5. Next is y equal to x plus 1. So we are getting 5 plus 1. It's not 6, it's 5 plus 1 because it's a text. But when I use eval function, it's able to add 5 plus 1 and gives a value of 6. So that is a use of eval function. Similarly, if you want to do any division, you can use eval function and divide. Just that you will get an integer value, you will not get a floating value. So 7 by 3, you are getting 2. That only the integer part is outputted. Now, if you are interested in getting the decimals as well, or if you want it to be floating value, precise value, you can use syseval function, sysevalf function for floating. Now, the same operation when you do with sysevalf 7 by 3, it will generate a value of 2.33 something, because you are able to get in decimals now. Let's look at %str function next. Now I will show you a wrong approach first, then we will look at the right way. I am creating a macro variable p. The value of p is prop print data equal to ds and run. So this is the value of macro variable p, the entire area that I have highlighted. So when I print p, let's see what it's printing. Let me first clean up the log window and rerun the part. So p is ideally it should be until run semicolon, but it's printing only, it's showing when you print p, it's showing only until dsn. So it's omitting the run part, because the issue is actually when you write a macro, we create a macro variable, and if the macro value contains a semicolon, it will not be considered as a semicolon, but it will be considered as a end of the macro statement, end of the statement. That is one issue. So if you want to put all this value into a macro variable, it is possible when you use a %str function. So this entire thing is considered as a macro value. Here, this semicolon is not considered as an end of a statement, and this run statement is also not interpreted as the end of a statement, but it is interpreted as a text value. So now when you run it, let's clean up the log window and run it again using the %str function. And now you see the value of p is shown as prop print data equal to ds and run. So they including the semicolon and the run statement are now part of the macro variable p. That's why we need to use %str function whenever our macro value contains a semicolon or a run statement, something that shows that is actually a keyword or a something that is can be interpreted by SAS. Next, we are seeing what is Nrstr function. So again, we'll see the wrong way first, so that you understand why we need to use this function. So let me use %str function and do write %raise n. I need the n and the percentage of raise. So this is actually a value. This is a value, and I want to mask this special character, and let's run it. I'm getting a warning, apparent symbolic reference to macro x not resolved. This issue comes because % is treated as a macro trigger. Macro trigger is, this is a macro trigger, %sign, because all the macro statements start with %. So it's treated as a macro trigger and it's searching for macro x. But ideally for us, it's not a macro call. It's not a macro trigger. It's actually a text % sign for us. We want this to be interpreted as a text, entire thing, until this highlighted part. In order to do that, str function won't help. So in order to mask special macro triggers like ampersand, %sign, for masking these two special characters, you have to use nrstr. So when you use nrstr, it will not throw any warnings. Let me clean it and run it again. It will not throw any warning now. Rather, it is treated as a text. And that's what we really intend to do. Similarly, you can see ampersand sign here. Now, I'm creating a macro variable p with the value of j and g. Let's say Johnson, something like that. So when I'm doing that, I'm just going to run it and see. I'm getting a warning, apparent symbolic reference not resolved. So again, if you have to apply the same scenario here as well with Nrstr. So when you use Nrstr, let me clean up the log window. When you use Nrstr, you don't get any warnings. So let me take this comment and stick it here as well. The first one always I showed you was a wrong. This is a wrong way. And when you use Nrstr, you are able to address this issue because here ampersand is treated as a text, not as a macro reference, not as a macro trigger. Usually ampersand is a referencing of macro variable, but here it's a text J and J, Johnson Johnson. So here it is treated, when you use as Nrstr function, it will mask the macro trigger. So I hope this is clear about Nrstr function as well. So we are done with Nrstr function, why it's needed. We have seen the wrong way of doing it and the right way. So two examples similarly. Next we look at %bcode function, bcode. This is useful especially when you are having unmatched quotation, like just one quotation. Use new truck. Generally whenever you put one quotation or a opening quotation mark, SAS will look for the closing one. It will look for a pair. Otherwise it will throw a warning. Now let's look at here scenario. We are creating a macro variable A with the values use new truck. And let's run A, and it's not resolved. Now you're getting a error actually, line generated from macro variable A. This is because you can see there is only one quotation. SAS is looking for the ending of next quotation mark to look for a pair. If it sees one, it will look for the second one, but it didn't find any, so it's throwing this error for you. Similarly, now let's try to use %str function. Will it help or not? Shouldn't help, it may not help. So let's run it. Click twice if it doesn't run, and run it twice, and again you see there's an error. So it's clear that even str function is not going to help us in this scenario. Now let's take refuge in nrstr function. Let's see if it's helping or not. So again we are getting the error. I'll clean up the log window. It's throwing the error. Now let's try bcode function. So we have seen that we cannot, str function is not helpful, %nrstr is not helpful. Now let's try with %bcode function. And here it's working. So finally we know why we want to use bcode function, because bcode function will help in treating this as a text, not as a quotation mark, where SAS will search for the closing quotation. So single quotation marks, single brackets, when you have something like that, use %bcode function. So this is pretty different from str and nrstr. That's why I showed you these examples where this function doesn't help, in order for you to help differentiate between %bcode and the other functions like str and nrstr. I hope this session was valuable to you in understanding macros, SAS macros. If you have any questions or any concerns, please feel free to drop it in the comment box. And if you liked the video, if you found it useful, helpful, please don't forget to subscribe it and like it. Thank you very much.